Okay, Module 8, VPN and IP security or IPSec concept. Okay, so objective of this module, first of all, explain how VPN and IPSec used to secure site-to-site, site-to-site, one-to-one, or remote access connectivity. Okay, so subtopic for this module, we have three main topic: VPN technology. We describe the benefit of VPN, type of VPN, regarding describe a different type of VPN, and IP security or IPSec. Explain how this the IPSec framework is used to secure network traffic. So virtual private VPN stand for virtual private network to create end-to-end private network connection. VPN is virtually in depth. It carries information within a private network, but that information is actually transported over a public network. A VPN is a private in that the traffic is encrypted to keep the data confidential while it is transported across the public network. Okay, meaning that this packet can travel along using a public network from, let's say, from here to somewhere else in US, in UK. So you can create that, VPN. So that's mean by this statement, Okay, or you can see this scenario. Okay, they're using a public. This one is a public network. So we can transport or send that packet or data through a public network to a specific receiver. All right. So modern VPN now support encryption features such as Internet Protocol Security, IPSec, and Secure Socket Layer, SSL. VPN to secure network traffic between sites. Okay, two technology they use to encrypt for the security, SSL and also Internet Protocol Security. Major benefit of VPN are shown in this table. First is a cost saving, So organization can use VPN to reduce their connectivity costs while simultaneously increase remote connection bandwidth, Security, benefit in security, encryption and authentication protocol, protect data from unauthorized access. Scalability, so VPN allow organization to use the internet, making it easy to add new user without adding significant infrastructure. Okay, virtually, So no need to put an extra physical infrastructure, infrastructure more on physical. So no need. So only virtually we can connect between one user to another user, right? Compatibility. VPN can be implemented across a wide variety of one-link options, including broadband technologies. Remote workers can use this high-speed connection to gain secure access to corporate networks. So site-to-site and remote access VPN. The site-to-site VPN is terminated on VPN gateway. Okay, VPN traffic is only encrypted between the gateways. Internal hosts have no knowledge that a VPN is being use. Okay. So a remote access VPN is dynamically created to establish a secure connection between a client and a VPN terminating device. Okay, so now we'll contact more on user and also sender. Yeah. So enterprise and service provider VPN. VPN can be managed and deployed as enterprise VPN. Second one, service provider VPN. Okay, for enterprise VPN, common solution for securing enterprise traffic across the internet, site to site, and remote access VPN are created and managed by the enterprise using IPSec and also SSL VPN. Yeah. For service provider VPN, so it will created and managed by the provider network. The provider use MPLS, multi-protocol level switching, at layer 2 or layer 3, to create secure channel between enterprise site. In fact, effectively segregating the traffic from other traffic consumer, segregating the traffic from other customer traffic. Okay. All right. So there are two types: enterprise and also service provider. Type of VPN: remote access VPN. Okay, remote access VPN let a remote and mobile user, securely connect to the enterprise. Okay, this one we have end user and this. Yeah. Remote access VPN are typically enabled dynamically by the user when secured and can be created using either IPSec or SSL. Yeah, secure socket layer. So clientless VPN connection, the connection is secure using a web browser SSL. Client-based VPN, VPN client software such as Cisco AnyConnect secure mobile client must be installed on the remote user and device. Okay. Okay, this one. So SSL VPN. SSL use the public key infrastructure and digital cert, digital certificate to authenticate peers. The type of VPN method implemented is based on the access requirement of the user and the organization IT processes. The table compare between IPSec and also SSL remote access deployment. Okay, so we have IPSec compare with the SSL, and then we look for application supported. Okay, so extensive for IPSec, where all IP is a base, all IP based application, but for SSL, limited for only web based application and file sharing. Yeah, authentication strength for IPSec, which is we can compare to the SSL. So IPSec can achieve a strong security features, especially on authentication, using two-way authentication with share keys or digital certificates. Yeah, but moderate where one-way or two-way authentication only. Okay, for the SSL, you cannot apply this digital cert on, but for this one, for I'm not sure current, current, this one maybe in couple of years back. Okay, according the notes written, Okay, maybe in future we can have this kind. Okay, for encryption strength, yeah. So for IPSec, they're using 56 to 256 bits. Okay, and then compared to this, they only support 40 to 256 bit. Little bit similar, yeah, for the strength on encryption. Connection complexity for IPsec is medium, yeah. Require VPN client to install on a host. Okay, but for SSL require web browser only. Okay, on host. So depends on the how good your web browser. Okay, so connection option, yeah, limited only specific devices with specific configuration can connect. Okay, all right. Extensive because any device with web browser can connect. So this one is compared to this. So SSL on web browser, of course, we can provide lots of option, yeah, compared to the IPsec. So site-to-site IPsec VPN. Site-to-site VPN connect networks, yeah, across an untrusted network such as the internet, and hosts can send and receive normal unencrypted TCP IP traffic through VPN gateway. Yeah, the VPN gateway encapsulates and encrypts outbound traffic from a site and sends the traffic through the VPN tunnel to the VPN gateway at the targeted site. Yeah, the receiving VPN gateway strip the header, decrypt content, and relays, yeah, the packet towards the target host inside its private networks. Okay, all right. So GRE over IPsec. Generic routing encapsulation, yeah, GRE is a non-secure site-to-site VPN tunneling protocol. Okay, GRE tunnel can encapsulate, yeah, various network layer protocol as well as multicast and broadcast traffic. GRE does not by default, yeah, support encryption, and therefore it does not provide a secure VPN tunnel. So GRE packet can be encapsulated into IPsec packet to forward it securely, yeah, to the destination VPN gateway. Standard IPsec VPN, which is for non-GRE, can only create secure tunnels for unicast traffic only. Yeah. Encapsulating GRE into IPsec allow multicast routing protocol updates to be secured through a VPN. The term used, yeah, to describe the encapsulation of GRE over this tunnel or IPsec tunnel are passenger protocol, carrier protocol, and also transport protocol. Passenger protocol, this is the original packet that is to be encapsulated by GRE. It could be either IPv4 or IPv6 packet, and also a routing update and many more. Carrier protocol, GRE is the carrier protocol that encapsulates the original passenger packet. Transport protocol, this is the protocol that will actually be used to forward the packet. So this could be IPv4 or IPv6. Yeah. All right. So this one transport protocol for IP, this one carrier protocol, and this is passenger protocol. So we embed inside here this either IPv4 or IPv6. For example, branch and HQ need to exchange OSPF routing information over an IPsec VPN. Yeah. So GRE over IPsec is used to support the routing protocol traffic over the IPsec VPN. Specifically, the OSPF packet, for example, passenger protocol will be encapsulated by GRE, this GRE, which is carrier protocol, and subsequently encapsulated in IPSec VPN tunnel. Okay, this is the scenario. So the encapsulated, okay, the word they use encapsulated, so mean from our understanding, they combine all together, they embed all together inside one tunnel, we call this IPSec VPN tunnel. So that's why you can use IPv4 and IPv6 together, okay, in order to use this GRE over IPsec. Dynamic multi-point VPN, site-to-site VPN, IPsec VPN and GRE, over IPsec are not sufficient when the enterprise add many more sites. Okay, there's some extension, we create more sites, so not sufficient on that. So dynamic multi-point VPN. So they use dynamic multi-point VPN, or the short form DM. VPN is a Cisco software solution for building multiple VPN, okay, in an easy, dynamic, and scalable manner. The MVPN simplify the VPN tunnel configuration and provide a flexible option to connect a central site with branch site. It uses a hub and spoke configuration to establish a full mesh topology. Okay, try to recall this hub and spoke configuration. Spoke site establish secure VPN tunnel with the hub site. Each site is configured using multi-point, a GRE or multi-point generic routing encapsulation. The MGRE, tunnel interface allow a single GRE interface to dynamically support multiple IPsec tunnel. Spoke site, can also obtain information about each other and alternatively build direct tunnel between themselves using this architecture, spoke to spoke tunnel. Okay. IPsec virtual tunnel interface, IPsec virtual tunnel interface, or VTI, simplify the configuration process required to support multiple site and remote access. IP security VTI configuration applied to a virtual interface instead of static mapping the IPsec session to a physical interface. IPsec VTI is capable of sending and also receiving both IP unicast and multicast encrypted traffic. Okay, both of that. Therefore, routing protocol are automatically supported without having to configure GRE tunnels. IPsec VTI can be configured between site or in hub and spoke topology. Okay. Service provider for MPLS VPN. Today, service provider using MPLS in their core network. Traffic is forwarded through the MPLS backbone using label. Traffic is secure because service provider customer cannot see each other traffic. MPLS can provide client and manage VPN solution. Therefore, securing traffic between client side is the responsibility of the service provider. There are two types, for this solution or MPLS VPN solution. Layer 3 MPLS VPN. Okay, the service provider participates in customer routing by establishing a peering between the customer router and also provider routers. Okay, Layer 2 MPLS VPN, the service provider is not involved in the customer routing. Instead, the provider deploy a virtual private LAN service or VPLS to emulate an internet multi-access LAN segment over the MPLS network. Okay, no routing is involved totally. Yeah, the customer router effectively belong to the same multi-access network. So these two solutions provided by service provider, IP security or IPSec. Okay, this video, this video will cover the following: the purpose of IPSec and some protocol in IPSec, which is AH, ESP, SA, and IKE. Okay, let me run this video. First, we go for
Internet Protocol Security, or IPSec. If we start with its history, we can see that the internet was not designed with security in mind. At that time, it was a private controlled environment. It wasn't the giant public internetwork of things that it is today. TCP/IP wasn't designed with embedded security as a foremost concern, because at that time it wasn't envisioned as to what it would become. Security, when it was implemented at higher layers, like SSL or Secure Socket Layer for HTTP and FTP, and Secure Shell for remote command line interface connections. But what about other applications that needed to be secured or need security? IPSec was designed to solve this problem, to implement security for IPv4 and IPv6 at the internet layer, therefore securing all of the applications and protocols in the upper layers above it. IPSec provides us with some basic things that are needed in security. One, authentication for data origin, being able to authenticate that your data came from where you think it came from, integrity, that it wasn't changed en route, and protection against replay attacks if the information or the data was intercepted, like in a man-in-the-middle attack. AH, or authentication header, can provide those things through IPSec. IPSec also provides encryption for data confidentiality, for keeping our data private, as well as authentication with integrity checks and protection against replay attacks. ESP, or encapsulating security payload, can provide us with those things. That's also part of IPSec. IPSec also provides us with negotiation of security associations and keys through ISACAMP, IKE, and Diffie-Hellman, or DH. IPSec has two modes: transport mode or tunnel mode. Tunnel mode is what's used in VPN tunnels. IPSec can be implemented in the kernel of the operating system, or it can be added to the stack. This is more typical. You have the application layer, which is in software, the transport layer, where we have TCP and UDP, that's in software, and the internet layer, or IP layer, which also exists in software. IPSec is added at the internet or IP layer and is implemented in software. In comparison to the network access layer, where we have the data link layer and the physical layer, which is implemented in hardware. When we use IPSec and have it added to the stack in an end device, it's called a bump in the stack. When IPSec is added to a network device, like a router, it's called a bump in the wire. In this slide, you have all of the protocols used in IPSec. IPSec is more of a suite or framework of protocols and security technologies than anything else. Let's take a look at the main protocols. The main protocols are AH, ESP, SA, and IKE. Now, AH, or authentication header, is more of a header than a standalone protocol, and it's waning in popularity because although it can provide the ability to authenticate data origin, that the data is from where you think it's from, as well as the integrity of the data, that it wasn't changed en route, it doesn't provide confidentiality or encryption. Authentication header also doesn't work with NAT firewalls. It can't traverse network address translation. Encapsulating security payload, or ESP, does provide confidentiality through encryption, and it can provide some of the same authentication methods like integrity checks to be able to verify the integrity of the data. ESP is more popular because of those reasons. Now, security associations are used to set up basically a contract or a recipe for how security is going to be handled from each device or from each end of the IPSec connection or tunnel. Now, security associations are built on IKE, or the Internet Key Exchange, and IKE uses the policies laid out in ISACAMP to set up these security associations. Now, there are two phases in IPSec. There's the Phase 1 Security Association and the Phase 2 Security Association. Phase 1 is used for management, and Phase 2 is used for data. Phase 1 creates the policy set, and Phase 2 creates the transform set. There's a single policy set used for management in Phase 1, and there are two, one inbound and one outbound, transform sets used for data. Now, all of the things that are set up in these two phases in these security associations are basically all of the security methods we're going to be using. So in Phase 1, what's negotiated is the policy set, and there we lay out the encryption that's going to be used. Let's say it's 3DES or AES. The hashing that's going to be used, either MD5 or SHA with HMAC, which is a keyed hash. The method of authenticating each end of the IPSec tunnel using X509 certificates with either pre-shared keys or public key, and the Diffie-Hellman group that's going to be used to share those keys across the internet. Phase 2 negotiates the transform set. Now, this is used to secure the data. Now, the transform set, we set up the encryption that's going to be used. Let's say we're going to be using ESP with AES encryption and a 256-bit key. And the hashing that'll be used for the integrity check. Let's say we're using ESP with a SHA hash with a keyed hash using HMAC. Those are the basic protocols, or the suite of protocols that you'll see in IPSec.
All right. Okay, we're done on that. Okay. Okay, IPSec technology, yeah. IPSec is an IETF, yeah, one of the organization, okay, who manage about the standard, yeah, in computer electronics and so on, yeah. So IETF standard that define how VPN, yeah, can be secured across IP networks. So IPSec protects and authenticate, yeah, IP packet between source and destination and provide this essential security function. First, through this security on this, yeah, IPSec, first they can achieve this confidentiality, yeah, use encryption. In order to achieve that, encryption algorithm to prevent cyber criminals from reading the content of the packet. And integrity means more on authentication, integrity of that data, yeah. Use hashing algorithm to ensure that packet have not been altered, yeah, between source and destination, yeah. So now focus integrity on the packet itself, yeah. So now this one for user origin authentication for sender and receiver, use the internet key exchange or IKE protocol to authenticate source and destination. And for exchange between sender and receiver, they use Diffie-Hellman yeah, were used to secure key exchange between them, right? So IPsec is not bound to any specific rules for secure communication. Yeah, IPsec can easily integrate new security technologies without updating existing IPsec standards. The open slot in the IPsec framework shown in the figure, yeah, can be filtered with any of the choices, yeah, that are available for that IPsec function to create a unique security association or SA. Yeah. Choosing the IPsec protocol encapsulation is the first building block of the framework. Yeah. IPsec first of all encapsulates, yeah, packet using AH or authentication header or ESP encapsulation security protocol. Yeah. The choice of AH or ESP establish which other building blocks are available. AH is appropriate only when confidentiality is not required or permitted. Yeah? ESP provide both confidentiality and also authentication. Okay. The degree of confidentiality, yeah, depend on the encryption algorithm. Okay, back to the algorithm, how good's your algorithm, and the length of key used in encryption. So that's a fundamental issue in order to provide the degree of confidentiality, okay, of the what we call this degree, the level of confidentiality using encryption. So in encryption itself depend on the length of the key. Okay, all right. The number of possibilities to try to hack the key is a function of the length of the key, and the shorter the key, the easier it is to break. So that's a fundamental issue, yeah, on encryption actually, yeah, in order to elevate the level of confidentiality. Okay, this one you already learned, I believe. You already learned in security class, yeah, in crypto as well. The encryption algorithm highlighted, yeah, in the figure are all symmetric key, yeah, all symmetric key crypto system, yeah. We have a dash 56-bit key, three dash, yeah, using three independent, which is 56-bit encryption key per 64-bit blocks, and AES offer three different key length 128 first, second 192 bits, and third 256 bits. Yeah, so under algorithm we have seal, yeah, is a stream cipher, which means it encrypts data continuously rather than encrypting block of data. Yeah, and seal uses 160-bit key, yeah, for the seals. So this is the confidentiality. So algorithm which related to this, yeah. Integrity. So more on data. So data integrity means the data has no change in transit. Yeah, that's mean integrity. A method of proving data integrity is required. Yeah, the hash message authentication code or HMAC. Yeah, HMAC is a data integrity algorithm. One of that guarantee the integrity of the message using the hash value. So this one in HMAC, yeah. So it got a message value hash value. So for the just now for the previous one, yeah, they're focusing on the key, the length of the key. But for authentication using this HSMAC, there depends on this hash value. Yeah. So message digest file or MD5 use a 1258-bit share secret key, and the secure hash algorithm SHA use 160-bit secret key. Okay, this one algorithm for integrity. Yeah. And for authentication, there are two IPSec peer authentication method. First, pre-share key, PSK. Yeah. So PSK value is entered into each peer manually. Yeah. Easy to configure manually, does not scale well, must be configured on every pair. So reverse Shamir and Edelman, yeah, RSA is quite well known this algorithm. Authentication use digital certificates to authenticate the peers. Each peer must authenticate its opposite peer before the tunnel is considered secure. Okay, this one very important. KYC, know your customer. This is very important. Okay, it's like KYC. Secure key exchange with Diffie-Hellman. Yeah, DH provide two peers, to establish a shared secret key over an insecure channel. Yeah, variation of DH key exchange, are specified as DH groups. DH group 1, 2, and 5 should no longer be used. Yeah, DH groups 14, 15, and 16 use a larger key size, with 2048 bits and 3072 bits, and also 4096 bit respectively. Yeah. Okay. So DH group 19, 20, 21, and 24 with a key size of 256 for this, 358 for this, 522 for this group, and the rest 254 this. 2048 bit support elliptical curve, cryptography ECC, which reduce the time needed to generate keys. Yeah, that's regarding Diffie-Hellman. So another video will explain the process of IPv4 packet with ESP in transport mode and tunnel mode.
In transport mode, there's only the single IPv4 header, which isn't changed. So you have the IPv4 header here, protocol 50, pointing to the fact that we're using ESP, and the ESP header is added. There's also an ESP trailer, and the ESP trailer tells us that the next header to look at is the TCP header in the encrypted IP data. So once this is decrypted, we'll have a TCP header next. Here's the ESP authentication data, and if this option is used with ESP, then we're going to also have authentication, meaning we're going to have an integrity check, or we're going to hash the entire, from ESP header to ESP trailer, we're going to hash all these fields so that we can verify the integrity of the data, that it wasn't changed. Now let's compare that to tunnel mode, which is used in VPN tunnels. In this case, the entire original IPv4 entire packet is encapsulated and encrypted. Not only the IPv4 data with TCP header and TCP data, including application layer data, but the original IPv4 header is encrypted along with the ESP trailer. Notice that the ESP trailer says the next header that to point to will be the IPv4 header because there's an original IPv4 header. There's an IP address and there's a new outer public IP address over here that was created. The new IPv4 address points to the fact that we're using protocol 50 ESP, and there's the ESP header and ESP trailer and ESP authentication data if we decide to have integrity checks or authenticated information through hashing. This is the type of packet that you would see in an ESP or VPN tunnel, with the original IP address and the new or public outer IP address.
All right. Okay, that's regarding IPSec transport and tunnel mode. Yeah. Okay, done. Okay, for this lecture, for this, 1 second, let me